Hello viewers, in today's session we have another important and interesting problem from beta gamma functions, and here we are going to evaluate this integral that is from 0 to 2 x raised to 5 over 2 divided by square root of 2 minus x dx with the help of some concepts from beta and gamma functions, right? So let us start. So let us first take this integral as I, right? Now here what we will do, will first make use of the method of substitution, right? And by using the method of substitution, we'll convert this integral into this form, that is the beta function, that is beta m comma n is given by the integral 0 to 1 t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So here we'll substitute x is equal to 2 times t, right? And using this substitution, we'll convert this integral into this form. So here x is equal to 2t, and t can be written as x over 2. Now let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of 2t, and then we can write 2 times d by dt of t, and the derivative of t with respect to t is 1. So we have 2 times 1, that is equal to 2. So now we can write dx is equal to 2 dt. Okay, so now here we'll change the limits accordingly. So here the lower limit is 0 and the upper limit is 2. So when x is equal to 0, then the value of t can be obtained from this relation. So t is equal to 0 over 2, that is 0. And when we have x is equal to 2, then the value of t can be obtained from again from this relation. So we have 2 over 2, that is 1, right? So now let us write this integral in terms of d. So now we can write the integral I as 0 to 1, and here when x changes from 0 to 2, t goes from 0 to 1, and for x we can write 2t. So we have 2t raised to 5 over 2 divided by square root of 2 minus 2t, and here we have for dx we can write 2 dt. So let us now simplify this expression. So we can now distribute this power, that is 5 over 2 and t. So we have 2 raised to 5 over 2 t raised to 5 over 2. Here we have 2 raised to 1 and dt, and in the denominator we have square root of 2 times 1 minus t. So taking 2 common in the under the square root sign. So now we can write 0 to 1, we have 2 raised to 5 over 2 and t raised to 5 over 2, and here we have 2 raised to 1, and taking square root of 2 to the numerator, we can write 2 raised to minus half, and here square root of 1 minus t can also be taken to the numerator. So we can now write 1 minus t raised to minus half, and here we have dt. So now let us further simplify it. So here we can collect all these 2's. So we have 2 raised to 5 over 2, then we have plus 1, and then we have minus half, and here we have t raised to 5 over 2 and 1 minus t raised to minus half, and here we have dt. So now simplifying this term, So we have 2 raised to, here we have 5 over 2 minus half is 4 over 2, that is 2, and 2 plus 1 is 3. So we have 2 cube, that is equal to 8, right? And taking 8 outside the integral, we have 8 times 0 to 1 and t raised to 5 over 2 and 1 minus t raised to minus half and dt. So now let us write I is equal to 8 times the integral 0 to 1, and t raised to 5 over 2 can be written as 7 over 2 minus 1, because 7 over 2 minus 1 is equal to 7 minus 2 over 2, that is 5 over 2. And here we have 1 minus t raised to minus half, and minus half can be written as half minus 1, and here we have dt, because half minus 1 is equal to minus half, right? So now we can see that this integral is similar to this one, right? And here if we compare this integral with this one, then here we have 0 to 1, 0 to 1, and t raised to m minus 1. So here we have t raised to 7 over 2 minus 1. So comparing, m is equal to 7 over 2, and here we have 1 minus t raised to half minus 1. So here we have 1 minus t raised to n minus 1. So comparing, again comparing, we can now write n is equal to half, right? So now we can write this integral I as 8 times the beta function, that is beta 7 over 2 comma half, right? So now we have to find out the value of this expression by using an important relationship between beta function and gamma function. So beta m comma n is given by gamma m times gamma n divided by gamma m plus n. So here we can now write gamma 7 over 2, then gamma half, and then we have gamma 7 over 2 plus half, right? Okay, so now let us find out the value of gamma 7 over 2. Now gamma 7 over 2 can be written as gamma 5 over 2 plus 1, and here we'll again make use of an important result, that is gamma n plus 1 is given by n times gamma n. So here the value of n is 5 over 2, so we can now write 5 over 2 times gamma 5 over 2, and again we can split 5 over 2 as 3 by 2 plus 1. So again applying this result to this one, so we have 5 over 2 times 3 by 2 and gamma 3 by 2. So let us further write gamma 3 over 2 as half plus 1. So we can now write 5 over 2 times 3 over 2 times half, and then we have gamma half. So here again we have used this result, right? So now this is 5 times 3 is 15, and here 2 times 2 times 2 is 8, and gamma half is given by square root of pi. So now in the denominator we have gamma 7 over 2 plus half. So we have 7 over 2 plus half is 7 plus 1 over 2, that is gamma 7 plus 1 is 8, 8 over 2, that is gamma 4, and gamma 4 is equal to 3 factorial, that is equal to 6, right? Because we know that gamma n plus 1 is equal to n factorial, where n is some positive integer. So now we can write the value of this integral I as 8 times gamma 7 over 2, which is 15 over 8, and here we have root pi, and gamma half is square root of pi and divided by uh, this expression, and this is equal to 6, right? So now this 8 and this 8 get cancelled, and we have 15 over 6. Root pi times root pi is pi, and again simplifying, this is 3 times 5, and 3 times 2 is 6, so we have 5 pi over 2, right? So viewers, the value of this integral I is 5 pi divided by 2. Hello viewers, in today's session we are going to discuss two important problems from integration, and here we have to evaluate these two integrals with the help of the concept of beta and gamma functions, right? So let us solve these integrals one by one. So let us first consider this integral, and let us call this integral as I, right? So here we'll solve this integral with the help of beta and gamma functions. So let us start with the method of substitution, right? So the method of substitution reduces this integral into the beta function, which is defined as beta m comma n, that is equal to the integral 0 to infinity, and we have t raised to m minus 1 divided by 1 plus t raised to m plus n and dt, right, where m and n are greater than 0. So here we'll first reduce this integral into the beta function, and let us first take x square is equal to t, right? So x can be written as square root of t. Let us differentiate x with respect to t. So we have dx over dt is equal to the derivative of square root of t, and the derivative of square root of t is 1 over 2 times square root of t. So now we can write dx is equal to dt, and here we have 2 times square root of t. So now let us change the limit. So here x varies from 0 to infinity. So when x is equal to 0, then the value of t can be obtained from this equation or this relation. So t is equal to 0 square, that is equal to 0. And when x tends to infinity, then from this relation we can see that t also tends to infinity. So when x changes from 0 to infinity, t also varies from 0 to infinity, right? So the limits remains the same. So now this integral I can be written in terms of t. So we have 0 to infinity, and x square can be replaced by t, and then we have 1 plus t raised to 2, and for dx we can write dt divided by, here we have 2 times the square root of t. So now let us rearrange the terms. So we can take half outside the integral, and we have 0 to infinity. Here we have t raised to 1, and here we have t raised to half. So we can take t raised to half to the numerators, and applying the laws of exponents, we can write 1 minus half, and here we have 1 plus t raised to 2 and dt. So let us write it like this, that is 0 to infinity, and t raised to 1 minus half is half, right? And here we have 1 plus t square, and here we have dt. So now this integral is reduced to this one along with this factor half, right? So now if we compare this integral with this one, then we can see that here we have half, and here we have m minus 1. So we can write m minus 1 is equal to half, and here we have 2, and here we have m plus n. So m plus n can be equated to 2, right? Because we wish to express this integral like this. So we can solve these two integrals for these two equations for m and n. So m is 1 plus half, that is 3 by 2, and from here n is 2 minus m, so this is 2 minus 3 by 2, that is 4 minus 3, that is half, right? So now we can write this integral as half and 0 to infinity, and t raised to half can be written as m minus 1. M is 3 by 2. So here we have 3 by 2 and minus 1, and then we can write 1 plus t, and here we have 2. So 2 can be written as m plus n. M is 3 by 2 and n is half, right? Okay, so now this integral is exactly of this form. So we can now write it as half, and beta function, that is beta m comma n. M is 3 by 2 and n is half. So now we have to find out the value of this beta function using the relationship between beta function and gamma function. So beta m comma n is related to gamma function as gamma m. Then we have gamma n, and then we have gamma m plus n. So here we have half, we can write gamma 3 by 2, then we have gamma half, and here we have gamma 3 by 2 plus half, that is m plus n, and m plus n is 2, so here we can write 2. So now the integral I is equal to half and gamma 3 by 2. The value of gamma 3 by 2 can be written as gamma half plus 1. So we can split 3 by 2 like this, half plus 1. So we have half times gamma half, right? Using this result, that is gamma n plus 1 is equal to n times gamma n. So now gamma half is equal to square root of pi. So now we can write half, and here gamma 3 by 2 is half times square root of pi, because gamma 3 by 2 is half times gamma half, that is half root pi, right? And gamma half is square root of pi, and in the denominator we have gamma 2. Gamma 2 can be written as gamma 1 plus 1, that is 1 factorial, that is equal to 1, right? Because we know that gamma n plus 1 is equal to n factorial, where n is some positive integer, right? So here we have 1, so this is half times half is 1 over 4, and here root pi times root pi is pi, right? So we have pi over 4. So the value of this integral I is equal to pi divided by 4. So now let us consider the second problem. So here let us take this integral as I, right? And here also we'll start with the method of substitution, right? And then we'll convert this integral into this form. So let us substitute here. T is equal to x raised to 6, right? So x can be written as the sixth root of t, that is 1 t raised to 1 over 6. Now let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of t raised to 1 over 6, and applying the power rule, that is the derivative of t raised to n is n times t raised to n minus 1. So here the value of n is 1 over 6. So we have 1 over 6 t raised to 1 over 6 minus 1. that is 1 over 6 t raised to 1 minus 6 over 6, that is 1 over 6 t raised to minus 5 over 6. So now we can write dx is equal to 1 over 6 t raised to minus 5 over 6, and here we have dt, right? Okay, so now let us change the limits accordingly. Here x varies from 0 to infinity. The lower limit is 0, the upper limit is infinity, right? So when x is equal to 0, then the value of t is given by this relation, that is 0 raised to 6, that is 0. And when x tends to infinity, then from this relation we can easily conclude that t also tends to infinity, right? So when x varies from 0 to infinity, t also varies from 0 to infinity. So in this case also the limits remains the same. So now let us write this integral I in terms of t. So we have 0 to infinity, then we have x raised to 4, right? So here x is t raised to 1 over 6. So we have t raised to 1 over 6, and then we have 4 here, and x raised to 6 can be written as t, and this is t plus 1. And for dx we can write 1 over 6 and t raised to minus 5 over 6, and here we have dt. So now let us rearrange the terms, and taking 1 over 6 outside the integral, so we have 1 over 6 0 to infinity, and here we have 4 over 6, right? And here we have t raised to minus 5 over 6. So applying the laws of exponents, we have t raised to 4 over 6 minus 5 over 6, and in the denominator we have simply 1 plus t, and 1 plus t can be written as 1 plus t raised to 1, and here we have dt. So now we can write 1 over 6 0 to infinity, and here 4 minus 5 is minus 1. So we have t raised to minus 1 over 6, and here we have 1 plus t raised to 1 and dt, right? So following the same steps which we have done in evaluating the first integral, let us compare this integral with this one. So here we have minus 1 over 6, here we have m minus 1. So we can now write m minus 1 is equal to minus 1 over 6, and m plus n is equal to 1, right? So from here m is 1 minus 1 over 6, that is 6 minus 1 over 6, that is 5 over 6, and the value of n is 1 minus m, that is 1 minus 5 over 6, that is 6 minus 5 over 6, that is 1 over 6, right? So now we can write this integral I as 1 over 6. We have 0 to infinity, and t raised to minus 1 over 6 is m minus 1, and m is 5 over 6. So we can write 5 over 6 minus 1. Here we have dt, and 1 plus t raised to 1. 1 is m plus n, right? M is 5 over 6, and n is 1 over 6. So 5 over 6 minus 1 is minus 1 over 6, and 5 over 6 plus 1 over 6 is equal to 6 over 6, that is 1, right? So this integral is now exactly similar to this one. So we can now write 1 over 6, and we have the beta function, that is beta m comma n. M is 5 over 6, and n is 1 over 6. So let us now calculate the value of this expression. So using the relationship between beta function and gamma function, we have gamma 5 over 6, then we have gamma 1 over 6, and here we have gamma 5 over 6 plus 1 over 6, right? So now I can be written as 1 over 6, gamma 5 over 6, gamma 1 over 6, and in the denominator we have gamma 5 over 6 plus 1 over 6 is simply 1, gamma 1 is 1, right? So in the denominator we have 1, and now to evaluate this expression we have to make use of Euler's reflection formula. So now Euler's reflection formula goes like this, that is gamma 1 minus n times gamma n is equal to pi divided by sine n pi, right? And if we take n is equal to 1 over 6 in this result, then we have gamma 1 minus 1 over 6, and then we have gamma 1 over 6, and that is equal to pi divided by sine pi over 6. So gamma 1 minus 1 over 6 is gamma 6 minus 1, that is 5. So we have 5 over 6, then we have gamma 1 over 6, and this is equal to pi divided by sine pi by 6. Now sine pi by 6 is sine 30 degrees, that is equal to half, right? So here we have half, taking this half to the numerator, we have 2 pi. So this product, that is gamma 5 over 6 times gamma 1 over 6 is 2 pi. So let us substitute this value over here. So we have I is equal to 1 over 6 times 2 pi, and here 2 times 3 is 6. So we have pi over 3. So the value of this integral I is equal to pi over 3, that is pi divided by 3. So viewers, this is how by the application of beta and gamma functions we can easily evaluate these kind of integrals. Hello viewers, in today's session we are going to discuss another application of beta and gamma functions, and in this class we are going to evaluate this integral where we have the integral from 0 to a x raised to 4 multiplied with the square root of a square minus x square, right? So here we'll solve this integral with the help of some important results from beta and gamma functions, and first of all we'll apply the method of substitution, right? So applying the method of substitution reduces this integral into the beta function, that is beta m comma n, which is defined by this integral, that is 0 to 1, and we have t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0, right? So by method of substitution we'll first reduce this integral to the beta function, right? So let us first take this integral as I, and let us substitute here this x square is equal to a square t, right? So that we can take a square common. Okay, so now we'll take x square is equal to a square times t, so that x is equal to square root of a square t, and x can be written as a times square root of t. So now let us differentiate x with respect to t. So dx over dt is equal to a times the derivative of square root of t. So here a is a constant. So we have a times 1 over 2 times square root of t, because the derivative of square root of t with respect to t is 1 over 2 times square root of t. So now we can write dx is equal to a dt over 2 times square root of t, right? Okay, now let us change the limits. So here the limits of integration vary from x is equal to 0 to x is equal to a. So a is the lower limit, and sorry, here we have 0 as the lower limit and a as the upper limit. So when x is equal to 0, then we can find out the value of t from this expression. So t is x square over a square. So when x is equal to 0, t is 0 square over a square, that is simply 0. And when x is a, then t is a square over a square, and this is equal to 1. So when x varies from 0 to a, then t varies from 0 to 1. So now we can write this integral I in terms of t. So we have the limits t is equal to 0 to 1, and here we have x raised to 4. So we can now write x is equal to a times square root of t, that is a times t raised to half. So we have a t raised to half, and here we have 4. Then we have square root of a square minus x square. X square is a square t, and dx is given by a dt over 2 times square root of t. So now let us simplify this expression inside this integral. So we have a raised to 4, then we have t raised to 4 over 2, and here we can take a square common. So we have 1 minus t, and here we have a dt over 2 times t raised to half, right? So now we can take here the square root of a square. So we have a raised to 4, then we have t raised to 4 over 2 minus half, right? Here we have t raised to half. So taking t raised to half to the numerator, we have 4 by 2 minus half. Here we have a times square root of 1 minus t, and then we have a dt over 2. So now we can collect all these a's. So we have a raised to 1, a raised to 1, and here we have 4. So 4 plus 1, 5, 5 plus 1 is 6. So we can take a raised to 6 outside the integral. Here we have 2, and then here 4 minus 1 is 3. So we have t raised to 3 by 2 times square root of 1 minus t, and here we have dt. So now we can write a raised to 6 over 2, 0 to 1, t raised to 3 by 2, and 1 minus t raised to half, and here we have dt. So we can write here 1 over 2 for this radical sign, that is the square root. So now if we compare this integral with this one, then we have 0 to 1, and here we have t raised to m minus 1. Here we have t raised to 3 by 2. So we can now write m minus 1 is equal to 3 by 2, and here we have 1 minus t raised to n minus 1. Here we have 1 minus t raised to half. So n minus 1 is equal to half. So we can now write n minus 1 is equal to half. So we can now solve these two equations for m and n. M is 1 plus 3 by 2, that is 5 over 2. And n is 1 plus half, that is 3 by 2, right? So now I can be written as a raised to 6 over 2. We have 0 to 1, t raised to 3 by 2. So 3 by 2 is equal to m minus 1, and m is 5 over 2. So we have 5 over 2 minus 1. And then we have 1 minus t raised to half. Half is n minus 1. N is 3 over 2, and this is 3 over 2 minus 1. and dt. So now this integral is exactly similar to this one, right? So we have here a raised to 6 over 2, and this integral is equal to the beta function, that is beta m comma n. M is 5 over 2 and n is 3 over 2. So now we have to find out the value of beta 5 over 2 comma 3 over 2. So now let us make use of the relationship between a beta function and gamma function. And the beta function is related to the gamma function by this relation, right? So we have beta m comma n is equal to gamma m times gamma n divided by gamma m plus n. So here we can now write I is equal to a raised to 6 over 2. Then we have gamma 5 over 2, gamma 3 over 2, and gamma 5 over 2 plus 3 over 2. So this is a raised to 6 over 2. Now see, gamma 5 over 2 and gamma 3 over 2 can be calculated by using this relationship, that is gamma n plus 1 is equal to n times gamma n. So gamma 5 over 2 is equal to gamma 3 over 2 plus 1. We can split 5 over 2 as 3 over 2 plus 1. Then we have this formula, 3 over 2 times gamma 3 over 2 and 3 over 2. Gamma 3 over 2 can be written as half plus 1. So we have 3 by 2 times half and gamma half, right? So this is 3 over 4 times gamma half. Gamma half is equal to square root of pi, right? Okay. So now we have gamma 3 over 2 and gamma 3 over 2 is equal to half times gamma half, that is half times square root of pi. So here we can now write 3 by 4 square root of pi for gamma 5 over 2, and for gamma 3 over 2 we can write half root pi, and in the denominator we have 5 by 2 plus 3 by 2. So 5 by 2 plus 3 by 2 is 8 over 2, and 8 over 2 is 4, right? So here we have gamma 4, and gamma 4 is equal to 3 factorial, because we know that gamma n plus 1 is equal to n factorial for any positive integer, right? So gamma 4 is equal to gamma 3 plus 1. So we have 3 factorial, that is 3 times 2 times 1, that is 6. So here we have 6. So now here simplifying this expression, we have 3a raised to 6, and then root pi times root pi is pi, and here we have 2 times 4 is 8, 8 times 2 is 16 times 6, right? And then we have 3 times 2 6, and this is pi a raised to 6 divided by 16 times 2, that is 32, right? So viewers, the value of this integral is equal to pi over 32 times a raised to 6. Hello viewers, in today's session we are going to discuss another important problem from integration, and in this class we are going to evaluate this important integral where we have 0 to a dx over square root of ax minus x square, right? So in this class we'll solve this integral with the help of the concept of beta and gamma functions, right? And before applying the concept of beta and gamma functions, let us first apply the method of substitution. So let us first take this integral as I, right? Now see, we can also write this integral as square root of x times a minus x. So taking x common from ax and x square, we can now write square root of x times a minus x. So let us further write it as dx over square root of x times square root of a minus x, right? Okay, now we can write 0 to a, and here we have dx, and here square root of x can be written as x raised to half, and here we can write a minus x raised to half, right? Okay, now let us make the substitution, that is x is equal to a times t, right? So that t is equal to x over a. So let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of at, and a is a constant. So we have a times the derivative of t with respect to t, that is a times 1, that is a. So we can now write dx is equal to a times dt. Okay, now here the limits of integration vary from 0 to a. So when x is equal to 0, which is the lower limit, the value of t can be obtained from this relation. So we have t is equal to 0 over a, that is 0, and when x is equal to a, then t is equal to a over a, that is 1, right? So now we can write this integral I as t is equal to 0 to 1, because when x varies from 0 to a, t varies from 0 to 1. And here for dx we can now write a dt, and here for x we can write at. So we have at raised to half, and here we have a minus at raised to half, right? So let us now simplify the integrand here. So we can now write 0 to 1. Here we have a dt, and from here we have a raised to half, then we have t raised to half, and from here we can take a common. So we have a raised to half times 1 minus t raised to half, right? Okay, so now we have 0 to 1, here we have a dt, and here we have a raised to half and a raised to half. So this is a raised to half plus half, that is a raised to 1, that is a. So here we have a, and here we have t raised to half times 1 minus t raised to half. So now we can cancel this a and this a. So we are now left with 0 to 1, and here we have dt over t raised to half and 1 minus t raised to half, right? Now let us take both these terms to the numerator. So we can now write I is equal to integral 0 to 1, and we have t raised to minus half, and here we have 1 minus t raised to minus half and dt, right? Okay, now let us convert this integral into the beta function, which is also known as Euler's integral of first kind. So we can now write t raised to minus half as half minus 1, because half minus 1 is minus half, and here also we can write minus half as half minus 1, and here we have dt, right? So now we can see that this integral is similar to our beta function, that is beta m comma n is given by 0 to 1 t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0. and this integral is similar to this one. So if we compare both these integrals, then the value of m is half and the value of n is also equal to half. So this integral I is now equal to the beta function, that is beta half comma half. So now we have to find out the value of this expression, that is the beta function, using the relation between beta function and gamma function. So now the beta function and gamma function are related by this expression, that is gamma m, then we have gamma n divided by gamma m plus n. So here I is equal to beta half comma half. So we have now from this relation gamma half, then we have gamma half, and then we have gamma half plus half. So now the value of gamma half is square root of pi. So here we have square root of pi, here also we have square root of pi, and here we have gamma 1. Half plus half is 1, and the value of gamma 1 is equal to 1. So here root pi times root pi is pi, and gamma 1 is equal to 1, so this is equal to pi. So the value of this integral I is equal to pi.